So this is a relatively difficult task of maybe pointing out what unmet needs still remain. But I think no matter which side of debate one comes from, whether you are the person and a sleep scientist who believes that REM sleep is just a vestigial remnant that actually fully developed human brain may not need, or whether, like I believe many of us here, strongly believe that REM sleep is hugely important, if not as important and maybe even more important in certain aspects as non-REM sleep is. So I have prepared a little bit of maybe sort of devil's advocate type of list of things that I think might be important for us to follow forward. And I have to say, I was really quite upset with Lina's start of the lecture, because Lina, clearly this Austro-Hungarian approach to a school of sleep physiology makes us all think along the same lines. And indeed, Lino started, and surprisingly, he was, I think, only one of few of our colleagues who've mentioned what I think is the major issue currently with the REM sleep and REM physiology. And that is that even in some of the best journals, papers are published really conceptualizing REM sleep as one homogeneous state, and it's anything but. We know, and it was Moruzzi, I believe, in the 60s, who recognized that there are different, very metabolically different states within the REM sleep that are recognized under the nomenclature of REM sleep, and potentially two major microstates of phasic and tonic REM sleep. And this beautiful conceptualization by Shimor and colleagues that was published just at the beginning of pandemic in Sleep Medicine Review is really worth looking into. And it showcases how diverse those two states are. So phasic REM and tonic REM are nothing similar. They're different in the way that the brain is responsive to environmental alertness, to microcircuitry that sleep, or rather various phasic oscillations or tonic passing through, also through the information processing. And increasingly, although unfortunately not every studies are doing what should be done, it appears that they may be differentially interplaying and contributing not just to the normal physiology, but also pathophysiology and major neurologic and psychiatric disorder where REM sleep is abnormal. So I won't bother you with some of those slides, because I think Lino did an amazing job in pointing out how important these microstates are, and obviously in epilepsy, it comes without surprise. And we know that various microstates of REM sleep also differentially potentially affect excitation and inhibition of cortical activity. The only thing, Lino, I would say, and I think you have tackled that, is that increasingly it appears that it would be rather phasic REM that has this suppressant anti-epileptic activity and not so much tonic. But again, given how little has been done in the field, this is at the moment predominantly guesstimation and based on only few studies. Now, what else? I was trying to share some of my pain. I've been recently asked to try to think of the ways how to inform neuromorphic technologies, all of those beautiful black Pandora's boxes. And I have to say, I have a few very brilliant, well, all of my team is brilliant girls at the moment, all girls who are very keen on Friston's theory of entropy and unified brain theory. But recently, Liboria and myself have had a conversation with a mathematician colleague of ours who told us, well, you know, you neuroscientists like to reinvent hot water, but there is a history to it. It's actually rather old adage that already Aristotle and in particular Bachelier at the beginning of 20th century have been talking about. And also, you know, if you really want to go down the cultural route, it's so-called Anna Karenina syndrome. And what are we really talking about? That the brain is actually most likely a very complex prediction machine that exists in a vastly unpredictable world. And as beautifully Tolstoy posited, there are many ways to be unhappy, but all happy families resemble each other. That happiness, that reaching of goal is rather expensive state. And therefore we all tend to little bit ditter and therefore maybe perform better than current artificial intelligence neuronal networks on the state of unhappiness in order to navigate this unpredictable world. Now, the question is there a point to the story? Does the REM play any role in this ability of brain to function? And we believe that it does, and it's not my invention. There is a lot actually in computational neuroscience where not necessarily the right vocabulary has been used, but there is an understanding that unexpected events in brain are recognized as surprising. They tend to evoke prediction error signatures, and that such mismatched expectations are often associated with emotional responses. Now, interestingly, if you think in terms of sleep being very important for this balancing prediction and surprise, and as we've discussed, discussing all these particular ways of looking at the brain, that the REM indeed might be there to summarize entropy level. Whether actually those emotions are just an ancient mechanism and present positive and negative balance cues that are designed to potently refine and generalize those internal models that our brain at any point tries to keep and therefore minimize prediction errors. So what I'm really talking about, it's all very hypothetical, but I think we are going there. Again, Lino, you are stealing the story of orexin, but I so agree with you. The only thing that I would slightly disagree, you mentioned that orexin tone is non-existent in REM, but which REM? And I would state that it may not be the story for phasic REM. Indeed, there is an increasing set of or body of work to suggest that maybe orexinergic inputs might be important for phasic REM, whereas on the other hand, the counterpart, the nemesis, although not in all aspects, melanin concentrating hormone inputs might be important in generation of tonic REM. Now, what are we really talking about? It's been recognized in other system homeostatic frameworks of body systems that at the level of lateral hypothalamus, those two melanoconcentrating hormone and orexin systems are extremely important. And it appears that diverse stresses and inputs with different strengths, weights, as presented on top of the slide, actually converge on individual neurons, and then those signals are integrated and utilizing error-based feedback systems, which is actually already rather recognized and well-known canonical engineering strategy to track a set point despite noise. And it does appear that our brain might be utilizing something similar. Where the new sort of kid on the block comes into the game is a set of I personally think rather genius work by Merschich, Flögel and Keller, who've been developing so-called cortical predictive processing model. And the idea is that apart from the canonical systems and where orexin and MSCH system appear to be balancing each other and collecting and spreading the inputs around the body in order to keep the homeostatic measure, if you want, measure of the entropy. Something similar seems to be occurring in our cortex as well. And it appears to be in particular happening at somatomotor cortices. And that might be of particular relevance to REM sleep. Here I am referring to rather elegant Brecht's concept of body model theory, where the idea consists that within a somatosensory superficial layers that provide context as well as storage of sensory memory, layers 6 to 4 are the ones that might be concentrating inputs that then lead to initiation of body simulations. This is not a new concept. There is a body of work to suggest that actually simulations of some of the very important adaptive body movements are possible by simulations in somatosensory cortex. I find that fascinating. Nothing like that has been ever taught when I was in medical school. And I think as medics, as scientists, we're still ignoring lots of that body of work that's coming before. Now, if one utilizes some of those already existing predictive processing models, one can potentially hypothesize that if bottom-up inputs to the cortical circuits increases unexpectedly, we could expect positive prediction error orexin neurons targeting layers such as 6B, which are known to be involved in homeostatic processing and the cortical connections. And in cases where there is a top-down prediction and activation of both the internal representation neurons and the top-down prediction from a higher area may in turn inhibit further orexin signals. Now, how that may or may not relate to phasic REM, which I guess many of you realized I was heading towards. There are some indications and beautiful work from Giulio and Chiara that suggests that potentially interplay, and not just from them, at those cortices may indeed be something that's happening during phasic REM. So not during a normal phasic REM, during normal phasic physiology, phasic REM physiology. And one can then imagine that potentially if something goes wrong and ultimately there is a loss of atonia, you may indeed start looking into the REM behavior disorder and or any other pathologies where this may be the case. Now, again, lots of beautiful body of data, lots of amazing work that our colleagues, if you've noticed, really predominantly talked about REM sleep. They didn't delineate between phasic and tonic, completely different metabolical states. And therefore, this might be indeed the case why to this date, there is so much of controversial data, whether REM is for forgetting, whether it is for remembering, whether it's for conceptualization, probably any of those things, but which particular type of REM contributes to what, we really don't know. Historically, traditionally, phasic REM appears to be more connected with visual imaging processing, emotional salient memory processing, whereas potentially tonic REM has been seen as a more integrative part of the sort of reactivation type of REM sleep, which may be guarding, for example, visual cortex from other sensory systems overtaking and in so many ways contributing to plasticity, which may be important if we think about utilizing neuromodulation of various REM sleep stages to tomorrow help congenitally blind people, or during indeed any traumatic injury, stroke, or so forth. What about then really REM's role in memory replay? And again, as mentioned, there are various studies, and REM reactivation has been shown in animals and in humans. It does differ from that occurring during slow wave sleep, in as much that it appears to be independent of sharp wave ripples. It tends not to show temporal compression, as indeed occurs at the microstates of non-REM, and mainly appears to occur during pre-task sleep. But again, I deplore you, up until very recent advent of silent neuroimaging, we really have no idea how these microstates interplay, influence each other, influence the non-REM microstates over several cycles of sleep. We know that the density of phasic REM increases with the further cycles, but how that may influence the overall structure of that beautiful symphony that sleep is, we don't know. We don't know how it influences, for example, various pathologies. Professor Benko showed beautiful body of work, and you know, there are lots of studies from 50s, 60s, from Soviet, from the German speaking areas, showing that manipulation of REM makes difference in depression. But do we know which microstate? Do we know why in mild depression there is early morning awakening? Do we know which biomarkers might be more representative when that mild is going to get into different types of severity of depression? And indeed, whether these antidepressants may differentially impact on those microstates? We don't. In regards to learning, however, there are some indications, for example, that phasic REM might be in particular linked with the pontogeniculo-occipital waves, which, as we know, play a very important role. But again, the story is getting more complex, more exciting. There is a work from monkeys, from Logothetes and groups in Japan, suggesting there are different types of pontine waves, maybe pre-REM, REM pontine waves that may have a different role to play in hippocampal milieu and various elements of information and learning processing. And some of the beautiful work by Gina Po has also suggested how that may be the case. So, for example, we know that theta activity may support memory consolidation, particularly of emotional memories, but inconsistent picture has been shown. And as Gina Po shown in some of the seminal experiments, that place cells that are reactivated during REM sleep in the peaks of theta oscillation, as long as they were encoded as novel, actually were enforced. However, those that were actually recording during troughs of theta oscillations were more likely to weaken and were going to actually probably be forgotten. Now, we also know that there is a subset of neurons, melanocortin, melanin concentrating hormones that project to corno-ammonis 2 region, which is again relatively newly recognized region that contributes to social memory and has a role to play in recognition of novel memory, which may be indeed playing back into our unified theory of the brain. So moving forward from that, I just wanted also to briefly mention that what I think is also a very important job and task ahead of us. And I wanted to pay a big homage to Steve Brown, whose work was close to some of the most genius work in circadian physiology, and who, unfortunately, before his untimely death, has actually shown that possibility how circadian physiology may indeed enable sleep physiology. So his team has shown that, for example, the forebrain synaptic transcriptome is organized by clocks, but it's really proteome that's driven by sleep. So why that may be important? Again, it might be instructive for us to think along the lines of clinical clinical interference in certain neurodevelopmental stages, where, for example, we know that there is a delayed or advanced sleep phase. So, for example, one of the things that I have been pondering about is how really prudent it is to suggest that the delayed sleep phase in adolescent phase is pathological. Would we not potentially think that really what's happening is that you are just pushing your circadian clock to prepare all the necessary material towards the later stages of sleep, where you are more likely to have REM sleep, which we know is important for pruning of those synapses during adolescence. And therefore, if we start meddling and trying to really correct it in any shape or form, we are messing up with potentially homeostatic adaptive process. And similarly, even during normal aging, whether the advanced sleep stage that some of our elderly, older patients may complain about, whether this is really just making sure that all the necessary material for synapses is there at the time when there is a more of the non-REM set of microstates and therefore sleep spindling. And hence, again, interfering with that, you may lose this adaptive element. But anyways, this is all very hypothetical. And this, in so many ways, I think shows to the younger generations how exciting this terra incognita still remains. And if you want to go even more bizarre and even more exciting, there is a lovely colleague of ours, Professor Gonfalon, a French neuroscientist, who's long been claiming that REM sleep really has developed due to the gravity. And he's been working closely with various sleep agencies, looking into astronauts' macro and microstructure, trying to prove that the REM sleep definitely at least decreases when microgravity or extreme conditions occur. Now, we probably disappointed him slightly. Obviously, there are various reasons why this may or may not be fully representative of the microgravity and, let's say, our sleep on the interstellar trips to Mars. But we ourselves have done the terrestrial microgravity model, so-called hyperbuoyancy model experiment. We exposed poor young men who were actually relatively well paid for 7 days to this contraption. They were only allowed 15 minutes off the bed during the day, and I had a very dedicated PhD student. So the participants complained of developing Stockholm syndrome in relation to PhD students who were timing them when they were sort of allowed to have those 15 minutes spread during the day. But a little bit joking aside, so we've even after only 7 days of whether you argue it was immobility or this microgravity state that we expose their bodies and their brains, we've seen changes. But one of the interesting changes was in REM. REM, it didn't reach statistical significance, but appeared to actually increase. It was different type of REM. And what appeared to be really most different when we compared last versus first were these very ultra low oscillation bursts, which we try to showcase our Latin knowledge and called columnosomnia. Why I mention this is because something similar has been shown by Chow and colleagues, and I think it's a rather interesting relatively ignored fact that showed that actually during REM, the default mode network recoupling occurs, which obviously is this coupled during the slow wave sleep, and that this dynamic interaction between two major systems, so unimodal sensory motor, that might remind you of the pictures I've shown previously, and the higher order association cortices occurs. And that these two systems become anti-correlated and fluctuate rhythmically and reciprocally alternating multi-second epochs, which are exact frequency of the changes we found from 0.1 to 0.001 hertz. Whether this is coincidence or something else remains to be seen. Thank you all very much. This has been a rather exciting long conference.